In the last video, we saw how to build data blocks in fastai for a pets example, right? In this video, what we're going to do is we're going to look at a Kaggle competition which happened 2 years back. The competition is about how you build an algorithm that identifies a disease called pneumothorax in the CT scan from lungs. Okay. I'm not a medical guy, so if I'm using the terminology is wrong, I'd apologize for any medical experts that are watching this video. But the idea is to show how to build a data pipeline, which is required to convert medical image format data to something which our algorithms will understand, right? Saying that, let's go and quickly look at what is the competition. I will give the link for the competition in the comments or description section in the YouTube for you to go and download. I've already created a pipeline which I would be sharing it in the coming days in the video link. The reason is I'm preparing this tutorial as a part of a long series where I want to explain how you can build a image segmentation model and probably reach the top 50 in Kaggle from end to end. I want to do that. So this is a sub part of it. So I'll just show you a glimpse of what is happening here. And once we have the right structure of data, what we'll do is we'll go and build the data blocks required from that from an empty Jupyter notebook. Okay. In the last video, we saw how data blocks is built, and we were lucky enough for fastai to prepare the data for us. But while doing Kaggle competition, the data generally comes in different formats. So let's start looking at what format the data is provided for this particular Kaggle competition. And let's see how we can convert this into a format that which we are comfortable with, so that building the data blocks is straightforward. Okay, I'll not be going through the complete notebook because that itself is a own video on its own, right? So what I'll try to do is I'll just try to show how the data is presented to us and how it was converted at the end, and then go and build a data block straight away. Okay, so you would want to install Kaggle API if you want to download the data. There are other ways to download, but one easy way to do is use the Kaggle API. Once you download the Kaggle API and you pass on a configuration file to this particular location, you're free to download the data. If you go to the Kaggle website and click on the data here, right, you can get this copy API command to clipboard. Okay, once you do that, you get a command similar to this. Okay, once you run this, it takes its own sweet time. In this case, it took 2 minutes 57 seconds to download the 3 GB data. It's a compressed data format. It's in zip. So what we want to do is we want to unzip the data. So let's go and quickly unzip the data. I've added this thing called --q to just say be quiet while uncompressing. I don't want the Jupyter lab to be full of that uncompressing data that you would know. Okay, once it's uncompressed, we can see that we have primarily 3 folders and 1 file. Okay, one is for test, one is for train, and one is pneumothorax. I'm not sure what it is, and train rle.csv. Okay, this is where basically the labels contain, and all the images are in a particular format called DICOM. To read that, we will install a package called PyDicom. fastai also has got some imaging library. I have not explored it, but on a future date, I would love to see what fastai offers and probably update this tutorial with fastai imaging rather than directly using PyDicom. I'm not sure if it makes sense today to do that, but I'll keep that for a future video. Some imports are happening. Let's take a look at what is the data format, right? We're reading the train rle.csv, which is going to contain data similar to this. Basically, it contains what is the image ID. This image is going to contain all the data of a particular patient in a format called DICOM. Okay, and it's going to have a value of -1 or an encoded binary mask. -1 means the patient is healthy, and if there's a mask, that means the algorithm has identified, or the annotators have annotated there is a bunch of pixels which probably has got pneumothorax, right? So it's encoded in a particular format for saving space, I would assume, in this particular way. So we need to figure out a way to convert this into a tensor of height and weight, right? So that we can pass it to the algorithms that we know, like unit or something. I did some data cleaning, which is pretty important. Okay, and you can see the DICOM image formats that are available here. Okay, and there's some distribution that goes on. Okay, and what we do at the end is we save all the files in a format that makes it easy for us to plot an image and get a mask. So basically what happens is you will get a folder structure similar to this: data, train, you have images, which is your training data. Okay, I think I should not open it, it's going to take some time. So what happens is in Jupyter Lab, whenever you open a folder with huge number of images, right, it's going to take some time to load. Okay, so it's generally a good idea not to open a folder with huge number of images. So as you can see here, from the custom DICOM format, we just changed it to a format, probably PNG or JPEG, I'm not sure. Let me pull this here. Oh, that also doesn't work. Okay, everything works, but it's going to take its own sweet time. So just let's close this. Okay, it's a PNG format. Okay, let's close this and let's go to the train. Okay, and masks will be also in PNG format. Okay, so now we know that we have got the data in a format that we understand. Let's quickly open a new notebook. Okay, inside the SIIM-ACR. Okay, and where we have the data folder also. And what we will do is we will try to create a data block from scratch as we did earlier. Okay, so what is the first step we will do? Just import whatever is the required package. And this is one thing I really love with fastai, and some few people may have complaints about it, but I personally love it. Particularly for exploratory, it's very useful. You have one line of import which takes care of most of the imports that you would need for the project, right? And we definitely need something called path. So here we are not going to use the untar, right? What Jeremy and fastai team did is they took away all the pain of creating the data pipeline in a particular data set in a proper way by downloading and doing any pre-processing, small minimal pre-processing that may be required, or setting up paths, everything done for certain data sets, right? But this Kaggle dataset is not part of the fastai dataset, so we have to do it on our own, and that's what we did in the previous one. We just showed what is the input and how the output was generated. So what is going to be the output, right? I would assume that's data. Okay, so because it has to be a string, it's not a variable, and that's what it throws. And then there's this amazing function called ls, which lists all the files inside that particular folder. It's always a good idea to test whatever code you have written rather than keeping on writing multiple lines of code. So I want to make sure the images directory are there in this particular folder. So I did a ls to see it's there. Now what we can do is we can go and create a data block. Okay. Now we will not be going step by step because we have already seen how to do it step by step in the last video, right? So what we are going to have is image block, right? That's going to be the input, and what's going to be the target? The target is also going to be an image, right? So let's also use an image block. If you've already done unit, you know that this is not the right thing to do, but for people who have not done, so let's just keep it that way. Okay, and what else you need? Okay, I'm not sure. Okay, so what we will do, we'll say get items. Okay, we know it's get image files, right? Get image files as a function. Okay, and then say dblock dot data sets and pass the source. What is the source? The path. Okay, and store it in something called dsets. Okay, once we have stored it, let's look at whether we are getting it the right thing. Okay, so we have got an image of RGB format 1024 and 1024, and here we have got a PIL image mode RGB 1024. Okay, let's see what it looks. Okay, this is an image of a CT scan, it looks fine to me, and this is also an image of a CT scan, which is not right because the target is not a CT scan, it's a mask, right? So what do? We pass a getY function. Okay, we have to tell fastai how to grab a target variable from the items. All right, and how do we do that? To do that, I would recommend us to take get image files. Okay, and pass the path information and see what happens. Right, it has got 21,350. Okay, that's good, and mostly images, and there is something else also, right? there are more files. So I would assume that it has read all the images and masks. So the path, let's say we make it images. Okay, and here also let's say we make it images. Okay, and now I don't want to list all the things, I want to read it clearly. Okay, so I know something went wrong here. Let's go and print. It's empty list. So okay, why is it empty list? Okay, let's say path. Okay, path is data, right? Slash train slash images. So what we'll do is here we'll change the path to path slash data train. Okay, and now we know we have images and masks, and now we can say path of images. Okay, now we know that we have 10,675, and we know that previously it was including the validation images, right? So what we need to do is, instead of this images directory, we have to change it to masks, right? Here it's mask, right? So what we'll do, we'll write a simple function, and what it's going to be, we always pick up the lambda, which makes life easier. And what is x? X is a path object, right? And what do we do? Let's convert that x into a string. Okay, now once we convert into a string, we can quickly say replace. And replace what? The word images with masks. Okay, okay, something is still wrong. What is wrong? Okay, train masks, this image is not there. Okay, why it's not there? Just now I said it's not masks, it's mask. Okay, so you always do mistakes, so it's a good idea to check it. Okay, so there's an empty mask here. Probably what we can do is we can try a couple of experiments, and okay, it's not, 0 is not the right choice because it's basically the target, right? Probably there'll be some index which has it, right? Let's say we want to figure out which index has got that. This is coming from, no, this is not coming from train ML, right? What we can do is, let's say for O in range of, okay, range of, let's say 10. Okay, and let's say data sets of that index. Okay, and get 1 and say sum. Okay, and let's just print this. Something went wrong. Why? It doesn't have sum. Okay, why it doesn't have sum? Because it's a PIL image, right? So what we will do is we'll convert that into a np.array, right? Now it should have sum. Okay, now we know 0 1 2 3 4 5, fifth index has got some mask. Now what we will do is we will go to the 5th index and see if there is a mask. Yes, there's a mask. There's one hacky way to find which image has got a mask, right? So now let's collapse this and let's go ahead. Let me keep it here so it may be useful for someone. Okay, we've got get y. So what we need to do, okay, when we're doing a Kaggle competition, one thing we really need is a fixed data set. We don't want it to be random in nature. That is, while doing experimentations, we should be able to compare different models, different attention layers, different heads. We want to do a lot of things, right? So what is very important is having a splitter, okay, which returns always a function which returns a data set which is consistent across runs, right? So what we will do is we'll still use a random split. Ideally in a Kaggle competition, I would use probably a k-fold and then pass indexes to it. So probably in the longer version of identifying the pneumothorax, what I'll do is I'll be using a probably k-fold. That's what I used for the competition when I participated in the competition. Okay, and in the random splitter, we know that we can set a seed. Okay, let's say seed 2021. Okay, and we definitely don't want the image to be of size 1024 and 1024, right? So let's also do an item transforms of and let's basically say when you read an item, convert into particular size, in this case 224. And let's say you want to apply some batch transforms. What is batch transforms? It's mostly the augmentations. Okay, I think there's a function called get. I hope I'm right. No. Okay, let's say AU of transforms. Okay, it basically returns a bunch of augmentations, and we can play with these parameters to slightly modify the augmentations that are applied. Okay, let's see if you're good. Okay, you passed up, and then say d sets of 0. Okay, this transformation generally applies when you do a data loader. And how do we check it, right? We can say dblock dot data loaders path slash images. Okay, and let's call it dls, and then say xp xbatch ybatch input targets is equal to dls dot one batch. Okay, and now let's go and say xp dot shape and yb dot shape. Okay, now we can see that our model has given this as an input and this is an output. Okay, but here the mask is of 3 channels. That's not what we wanted because it's a binary classification, right? It's whether the pixel is there or not. So what we can do is, instead of image block for segmentation, fastai gives a custom thing called mask block. Once you run a mask block, you would see that the shape is 64 224 224. Okay, so that's a good thing. Okay, so next what we want to try is we wanted to say d blocks. We want to make sure that everything ran well, right? The best way is to create a summary, okay, and pass the path. Okay, and if there are no errors here, okay, as we can see, there are no errors here. That means we're able to create a batch of data for inputs and targets. Okay, so we can go now and train the model. Okay, but there's still one caveat that we may want to look. Okay, what is that? Let's look at the value of yb. Okay, what we will do is, since it's a tensor, we can do some things like yb dot minimum, yb dot maximum, right? And we can see the maximum is 225. I told it's a binary classification, right? I mean, it's a segmentation problem, and we want to predict if each pixel is either 0 or 1. Okay, and we don't want the tensor mask to contain 0 and 255, right? So what we want to do it is, we want this value to be 1. And how do we do it? We apply a transformation called into mask here, right? Okay, it's not here. I think we can apply it either in item transforms. Okay, I'm not sure. I have used it. I'm not sure how it works. So let's just give it a try. Okay, I think we can apply this to either. Okay, we apply into float tensor for item and say div mask is equal to 255. It was 1, right? The value of the mask is divided by 1 earlier, right? Let's see if this is working, or it's going to throw some error for us. Okay, it worked. Okay, but since this is a transformation that can be applied for a batch size, we can get some substantial performance gains if we can push this to batch transforms. So let's push it to batch transforms. Okay, and let's do it like this, and let's put this in a list. Okay, and if you do this, you will get an error. Could not do one pass in data loader. There is something wrong in it. Okay, so what do we do when something is wrong? We hit the summary. I know what was wrong, but I just wanted to show you guys what went wrong, right? Applying list failed. Okay, basically the batch transformation expects a list of techniques, but all transforms gives a return to a list. Okay, that's why it was working earlier when we pass. I think now this should fix the issue, right? So now what we have done is we have prepared the data, okay, for training a image segmentation model using fastai unit learner or some other unit block, right? I hope that makes it clear how to build a data block. You can always try a few more experiments, take few more competition data, and try to build a data block. If you can build data block for 2-3 data sets, you'll have a good understanding of how building data block works, right? If you like the video, hit the like button and hit the subscribe. And if you want me to pick up some topic in fast AI or deep learning, you can comment it in the below comment section. And if I'm expert at it or if I can quickly learn it, I'll try to make a video. Hope you enjoyed the video. Thanks for watching. Bye bye.